Hello, welcome back to our tutorial for mechanics, and in our today's lesson we will be discussing motion in two dimensions. I remain Professor Obakayaku, Department of Physics. We're starting with projectile motion, and with that we'll start by defining what projectile motion is. Projectile motion can be defined as the motion of an object in an arc near the surface of the earth and under the influence of gravity alone. It's important to note that the path followed by a projectile is called its trajectory. Projectile motion comprises of horizontal motion with constant velocity and vertical motion with constant acceleration. These are the key things we need to know about. So looking at the diagram, we'll notice that we have a body moving in horizontal component, where a body is thrown from the point here. It moves at the velocity in the x direction is 0, then the y direction it continues to move. We have velocity v0 with an angle alpha. At every point we have the y component, the x component, and the velocity itself. At this point velocity becomes 0 in the y direction, then before you start proceeding downward. With this in mind, and we'll have the height of the projection. This is the range of the projection, that where the motion was kicked, either a ball or a stone was catapulted, and the range is like distance covered by the flight of the object that is thrown. So what we want to do is to prove the equations for time of flight, the height of flight, and then the range of the flight of the projection. So before doing that, we need to look at some assumptions. The assumptions in projectile motions are: 1, the effect due to air resistance is negligible; the effect due to curvature of earth is negligible; the effect due to rotation of the earth is negligible; and the acceleration due to gravity is constant over the range of motion. So this is rotation of the earth. Good. Now we are going to start by looking at equation of trajectory. The picture here shows somebody kicking the ball from the ground or the horizontal, and it moves in a projectile path or parabolic path. So what we're trying to look at now is to know the range of the flight, to know the highest distance made by the flight, which is the height of the flight, and then to know the range covered by the flight. In doing so, we need to state some basic components first before going to the proof. So when projectile is at highest point, velocity at y is 0. Remember from the diagram, I said the highest point velocity is 0. So even the velocity at the highest point, the velocity at y is 0, and also the velocity in the x direction is 0, because the body automatically stops at that point before decelerating. So an acceleration in x-axis is also 0. Like I said, that ball stops at the highest point before it starts to decelerate. So velocity in x direction is vx, v0 cos alpha. Remember, this is resolving component in the x-axis and y-axis. For the x-axis takes cos alpha, so v0 cos alpha, the initial velocity cos alpha, the angle it makes with the projection. And also for the trajectory, the acceleration at the highest point is minus g, acceleration due to gravity, while the velocity with respect to the vertical component, which is v0 y, initial velocity in the y direction, is going to v0 sine alpha. So to find the time of flight of projection, we will use the equation y equals to v0 yt plus half at squared. This equation is from Newton's equations of motion. If you look at the equation, where it's just resembling that of x equals to ut plus half at squared. So when the projectile reaches the ground at b, y is 0, so there is no more height. When the projection reaches point, then there is no height, y is 0. So it simply means y is equal to 0, which is equal to v0 yt plus half minus gt square. Remember, the acceleration due to gravity is minus g, and that's why we're having minus g here. So for the velocity in the y direction, remember, it is v naught sine alpha t. So v naught sine alpha, then times this t minus, because of the minus here, it affects the positive sign here, we'll have minus gt square. When you resolve this out, making t subject to the formula, you're going to have t equals to 2v naught sine alpha all over g. This equation here is called the equation of time of flight. So you have resolved the equation of time of flight. So we'll have our time of flight to be 2v naught sine alpha over g. To find the range, like I told you, the range is the distance from the point the ball is kicked or projectile is shot to the point where it drops to the horizontal. So to find the range, which is in the x direction, we know that distance is velocity in the x direction times time, where x is the range, OB. If you go back to the diagram, that was our range now is v naught st. So therefore the range is velocity in the x direction, this v naught s cos alpha, times the time of flight, which you just find out now is 2v naught alpha over g. Compute this out, you're going to have v naught, you're going to have v naught square, then 2 sine alpha cos alpha. In trigonometrical functions, 2 sine alpha cos alpha is the same thing as sine 2 alpha. Therefore, our range is v naught square sine 2 alpha all over g. Now we have computed for the range. Now is the time to look for the height. Like I said, there are 3 components we are trying to find: time of flight, range, and the height of flight, and the maximum height of the flight. And that we are going to use the Newton's third equation of motion, which is v square u square plus a square, a square, v naught u square plus 2as. Thus, from this equation, we know that at the highest point, our velocity is 0. Remember, at the highest point of flight, the velocity is 0, and the velocity for the y direction is v naught sine alpha, and then it's squared, minus, because there's a positive sign, and our acceleration due to gravity here is g minus g, so it becomes minus g. This is changing height, so h, the height. So solving this out, you are going to have 2gh equals to v naught sine alpha square. Therefore, h equals to v naught sine alpha square all over 2g. So opening up that bracket, you are going to have h equals to v naught square sine square alpha over 2g. So this is now the equation for the maximum flight observed by the projected body. For equation of a trajectory is just to prove that the trajectory itself is a parabola, and we all know that the equation for a parabola is just simply mx minus mx square, where the m itself are integers that are positive. So let us look at the equation. From the beginning, we know that velocity, the s, which is the distance, s is just velocity times time. Distance is velocity times time, and the y is this equation. So if we look at this equation, it simply means that our y equals to v naught y sine alpha t minus gt square. So from equation 1, our t is s v cos alpha. From this equation, the value of t is going to be s divided by v naught cos alpha. So substitute equation 3 into equation 2. You are going to have v naught sine alpha. Instead of having t here, you're going to have s, this value, v naught cos alpha, minus 2gt, another t here, squared. Sine alpha divided by cos alpha is tan alpha. Though, however, I've changed it to theta here, so it's alpha. They're all angle supposed to be alpha. So we have sine alpha divided by cos alpha is tan alpha. V naught and V naught will cancel out, so you are going to have tan alpha x minus half g x v cos alpha squared. If you remember, I told you earlier that the equation for a parabola is y equals to ms minus ms squared. If you look at this equation here by inspection, the tan alpha is like our m, which is a positive integer, and then our half g is also another positive integer, which is the second m, then x squared, this. So automatically all terms in equation 5 are constant except x and y. By examination, equation 5 is of the form y equals to ms1 plus ms2 x squared. So where m1 and m2 are positive constant, thus equation of trajectory is a parabola. So with this, we now agree that it is a parabola. So example 1, to support all the equations we have done, CR7 strikes a ball which leaves it off at an angle of 35 degrees to the horizontal with an initial speed of 40 meters per second. Assume the field of play to be level. Determine A, time of flight, B, the range, C, the maximum height of the ball. It's just to apply the equations like I said earlier. T is for time of flight, it's just T equals to 2v sine theta or 2v sine alpha over g. And we know the value 2 times 40, which is giving the velocity, then sine 35 is given. Put that into perspective and solve out. You're going to have a time of flight of 4.49 seconds. Question B. Apply the equation r equals to v cos theta t, where r equals, this is the velocity times time. So r equals to 40 cos theta t times 4.9. You are going to have 150.4 meter. However, this is straightforward to the answer. You can still apply the full equation of the range of the equation. Remember the range of the equation? This is it. This equation for range. R equals to V naught squared sine alpha over G. So if you apply that equation, you can also arrive at the same answer of 150.4 meters. For maximum height, same story. H equals to V naught squared sine squared theta all over 2G. So it's V naught square, because it's squared, sine squared theta, also everything is squared, then times 2g. The g here, remember g is acceleration derivative. In this equation, we are using g as 10, and you might use 9.8 depending on what is given to you, but in this very equation, we are saying it is 10. So in solving that out, you are going to have the maximum height reached by the ball kicked by CR7 Cristiano Ronaldo is 26.3 meter. Example 2. Suppose an object is thrown with an initial speed of 10 meters per second and an angle of pi by 4 with the horizontal. What is the range covered? Suppose the same object is thrown similarly in the moon. Will there be any change in speed? If yes, what is the change? The acceleration to gravity in the moon is 1 over 6g. Solution. And the range is u square sine 2 theta all over g. We know pi is pi over 4. And we know u, which is v naught, and then equals 10 meters per second. So in putting that in perspective for Earth, we are going to have the velocity 10 squared, which is given sine pi over 2. Why is this sine pi over 2? Remember, this is sine 2 theta. So if you put 2 theta, because they say theta is 2 theta, and theta is pi over 4. So 2 theta now is going to be pi over 4, pi over 4, and then solve that out. Do the calculations yourself. You see here, don't get confused. This is 2 theta, theta is pi over 4, so pi over 4, and then 2 divided by 4 will give you 2, so you'll be left with pi over 2, and that is why you're having sine pi over 2, and pi over 2 is 90 degrees, and sine 90 is 1. So 10 squared is just 100 and divided by 9.8. In this equation, we are using g as 9.8. And we end up having an approximation of 10.2 meter. The range when this is solved on Earth. If the same equation applies in the moon, which is this, is the same situation, but this time around, g is the acceleration to gravity on Earth divided by 6. For that reason, I have just done a quick straight answer to the story, because everything is the same, then times 6. So the device, so we know that this is r equals to g6, so 6 goes up here, and then you have r equals 6 times this value. So you are going to have 61.22 meter. Approximately a difference of 60 meter. We have an approximate difference. Because 61.22 meter, approximately 60, so there is a great difference between two, about 50 meters difference between Earth and the moon. But solve this out completely. Don't follow my method here. put the value of G here, then divide by 6, and then do the solving, so you get the same answer I have here. Example 3. Cristiano Ronaldo strikes a ball with an anti-continental ballistic shot on goal such that the ball moves with a speed of 30 meters per second at an angle of 30 degrees with the horizontal. The goal line is located at a distance of 75 meters from Cristiano Ronaldo. Will CR7 score a goal, neglect the air resistance, and take us into graph to be 10? Solution. First of all, we need to calculate the range of the shot that was struck by Cristiano Ronaldo. Put in all the values. Remember, the velocity is given 30 meters per second. The angle is also given. The angle is at 30 meters, 30 degrees. Then you solve out the whole sort of issues, and you end up having a range of 77.94 meter. If the ball will land, if the shot taken by Ronaldo will land at 77.94 meter, the question is, will he score a goal with this shot? Remember, the distance from where the shot was taken to the goal line is 75 meter. And if we have solved this to be 77.94, what you need to do to know if Cristiano Ronaldo will score the goal is to subtract, to see if this will be able to be subtracted, and then ball falls behind the 75 meter line. So this distance, we conclude that this distance is greater than the distance of the goal line, hence the ball will cross the goal line. Therefore, a goal will be scored by Cristiano Ronaldo. Funny, is it? Probably I'm biased by using Cristiano Ronaldo in my example. Sorry for those who don't like him. I just like him as a footballer. Thank you, and bye-bye. See you next time.